Hey guys, this is Mr. Krieger. We're going to do lesson 3 now. We're only going to do this first page together on the video. The rest of the lesson we'll do live together. If you remember, we learned how to do factoring before. You've practiced it, you've learned it in previous classes. And now we're going to do something called factoring the difference of cubes, the difference of perfect cubes. All right, it's in a sense, it looks similar to factoring perfect squares, except in this case, what you're given, and I'll show you an example first, you're given perfect cubes. Let's say instead of x, let's say this is a dots problem. Let's say x squared minus 9, where this is a perfect square, because obviously x squared, and 9 is a perfect square, and we know that we factor that by doing x plus 3 and x minus 3, so that's a difference of perfect squares. Now we're going to be learning about factoring perfect cubes. The interesting thing is, though, it doesn't only have to be a difference. It could actually be a sum of perfect cubes, too. I'll give you 2 examples. Here's a sum of perfect cubes. X cubed plus 8. X cubed is a perfect cube, it's to the 3rd power. Just like this was a perfect square, x cubed is a perfect cube. And 8 is a perfect cube as well. Remember, the perfect cubes are generated by doing 1 cubed, which is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64, and so on, right? So this is the sum of perfect cubes. This is a perfect cube, and this is a perfect cube. It's actually factorable, and I'll show you how to factor it in a minute. I just wanted to first show you what perfect cubes look like, and this is a sum of perfect cubes. So this is sum of perfect cubes. And it turns out you can also factor the difference of perfect cubes. I'll give you another example here. Let's say x cubed minus, let's pick 64. So this is a difference of perfect cubes. And this is also factorable. Now, how do we actually factor this? Well, the way it's factored is you're going to follow this formula. There's 2 formulas. The first formula is difference of cubes. Here's an example, a cubed minus b cubed. Now, it doesn't have to just be variable problems. It could also be numeric. It could have been a cubed minus 64, for example. But this is just general. What if you had a cubed minus b cubed? What's the rule? It's always going to factor like this, a minus b. So think about it. A cubed is the cubed of a, and the cube root is a, and the cube root of b cubed is b. So it's going to be a minus b, the cube roots of those things, right? And then it's going to be a squared plus ab plus b squared. When you see examples, it will become clear for you. But first I want you to notice the pattern, because when you see the pattern, you'll probably remember how to do this even without this formula. When you see the difference of perfect cubes, the first term is just a binomial, the cube root of that and the cube root of that, and it's going to be same. We're going to call this same sign, negative, negative. Then there's going to be a trinomial here. It's going to be a squared, and then there's going to be so it's going to be a squared of the first thing, a. Then the 2 terms, a and b, multiplied together. And then the last term, the last cube root times itself, b squared. And look at the signs here. So the signs are going to be like this. It's going to be same sign for the first part, for the binomial, then different, then positive. And it's always going to be this rule, same, different, positive. So this is same, this is different, and this is always positive. You might be saying, what do I mean by that, always positive? Well, if you look at the sum of perfect cubes, they almost look identical, except for the signs. Look, if it's a sum of perfect cubes, like plus, same, plus, that's the same. Different, opposite. Maybe we should say same, opposite. This was plus, this is minus, so it's opposite. Always positive. So this last term is always positive. So if you remember that, same, different, always positive, then you'll know what signs to put in. You got the binomial, you got the trinomial. With practice, you'll get the hang of it. It's actually pretty easy to follow this formula. Let me show you some techniques that you'll use to do this pretty easy. I'm actually going to write on a separate sheet of paper only because I'll be able to have extra room and I'll be able to write larger so you'll be able to see it. So we have a cubed plus 27, okay? Let's rewrite the terms as perfect cubes. So what we're gonna do is we're gonna take the cube root of that. We'll call that term a, and that is an a. And the cube root of that, what is the cube root of 27? It's 3. This is our a and this is our b. A is a and b is 3. Now we're gonna follow which formula? This formula. So we're gonna have a binomial and we're gonna have a trinomial. In the binomial, it's gonna be the same. These two things, just a binomial with the a and the b, a plus 3, same. Now, it's going to be this thing squared, this first term squared, a squared. The second term is going to be the a and the b multiplied together, that's going to be 3a. And the last term is going to be this term squared, so 3 squared is 9. Let's look at the signs. The format's always going to be the same. Remember, we've got same plus, opposite or different minus, always positive. Now we've just factored a cubed plus 27. That's how you do it. Let me go over again, and I'll use another example so you can understand. We'll do another example so you can follow along again, because maybe some of the details you might have lost them. So let's take this one, x cubed minus 64. Let's take our a and our b. A is x, it's the cube root of that thing. Cube root of x cubed is x. Cube root of 64 is 4. 4 times 4 times 4 is 64, so the cube root of 64 is 4. Gonna make a binomial and a trinomial. Put these two terms in here. I'm sorry, it's gonna be an x, and it's gonna be a 4. We're gonna start off with the same. Sign was negative originally, same. Now, this term squared, these two terms multiplied by each other, 4x, this term squared, which is 16. So check it out. All I do is square this, that comes first. Multiply these two, a and b together, that comes second. Square this, that comes last. Now we follow the format. Same, different, always positive. See? Same, different, always positive. This way you know what the signs will be. So this is this completely factored. By the way, you can't factor this. There are no numbers that multiply to 16 and add up to 4, so you don't have to worry about that. All right, let's go take a look at the next problem. So here we got something a little bit different. We have 2x cubed plus 128. Now 2 is not a perfect cube, but neither is 128. We're going to have to do factoring completely. First, we're going to have to do the GCF. GCF is 2. Pull out the 2. We get x cubed plus 64. Actually, it's almost like that. So we have the 2 as the greatest common factor, and now we've just got the same kind of factoring we've been practicing. So we're going to make our a and our b. A is the cube root of that, which is x. Cube root of x cubed is x. Cube root of 64 is 4. We have a 2 on the outside. We're going to have a binomial, and we're going to have a trinomial. X and 4, same sign. This term squared, x squared. These two terms multiplied by each other, 4x. This term squared, 16. Let's check the signs. Same, different, always positive. This is the factorization of this problem right here. Okay? So let's try the next problem. Okay, we got 8x cubed plus 64. By the way, this whole thing is a perfect cube. Should you pull out the 8? Let's see what happens if you factor out the 8. Greatest common factor, you get x cubed plus 64 divided by 8 is 8. Still good. This is also perfect cubes. This is the sum of perfect cubes. Let's follow the format. A is x, the cube root of that. B is 2, the cube root of 8 is 2. We're going to have an 8, we're going to have a binomial, we're going to have a trinomial. In this parentheses, we're going to have the a term and the b term, x and 2. Same sign, plus, plus. Now we're going to have our x squared, 2x, 2 squared is 4. Let's check the signs. The original is plus. Same, different, always positive. Same, different, positive. So this is how we factor this problem. All right, let's try the next one. 8x to the 6th minus 27. That's a little different. 8x to the 6th minus 27. So let's think this through. 8's a perfect cube. X to the 6 is a perfect cube. 27 is a perfect cube. A is going to be 2x squared. Why is that? The cube root of x to the 6th is x squared. B is going to be 3. The cube root of 27 is 3. We don't have any GCF here. We're just going to have a binomial and a trinomial. The binomial is just going to be A and the B. 2x squared and the 3. Let's check the sign. Same sign. The original sign was a negative. We're going to put the same sign there. Now, trinomial. A squared. So we're going to have to square that whole thing. Well, if we take 2x squared and multiply it by 2x squared, we get 4x to the 4th. Next term, we multiply these together. We're going to get 6x squared. And finally, this term squared, 3 squared is 9. Let's check the formula, the procedure. Same, different, always positive. Same, different, always positive. That's it. We've just factored this problem. And the last problem, do this last one together. A cubed, B cubed minus 125. So again, our A term is going to be AB. The cube root of this whole term is AB. The cube root of 125, that's going to be our B term. It's a little weird here because there's a B there, but this is a different B. The cube root of the 125 is 5. Follow the same format. Binomial AB, 5, same sign. Negative here is going to be a negative here. Now we're going to do this thing squared. AB times itself is going to be A squared B squared. Next term, we multiply 5 in that AB, so we get 5AB. Last term, 5 squared, 25. Let's see what the signs are going to be. Remember, it's going to be same, different, or opposite, always positive, and we've just factored it. So this is how you factor sums and differences of cubes, of perfect cubes. So hopefully this is clear, and you should be able to do the problems in the homework.